We're going to talk about translations of sine and cosine graphs. I highly recommend that you have the guided notes for this one. This is kind of a tricky topic, even though the ideas are simple. When you apply them, they're a little tricky. So what I'm going to do first is I'm just going to tell you in general what a horizontal translation is. So horizontal translations look like this. I'll explain this in the context of sine and cosine in a few minutes. So basically, if you have a function and then you've got like your x coordinate and then you have just immediately next to it either like plus or minus a number, and we'll call that number d for now, then this will shift your graph to the left or to the right. So if you have a minus d, it moves d units to the right. If you have a plus d, it moves d units to the left. So let's take a look. I think this is easiest to understand if you see it in action. So let's take a field trip to desmos.com. So to understand horizontal translations, I think it's actually better to use some other graphs first. So I'm here at desmos.com, and so I have x squared, so this is the dotted black line. Okay, so like I said, so translations are all about adding something immediately to the x. So like you're still kind of within the function. So see how I have this x plus 2 squared? So this is like inside with the x. So I want you to watch this graph here. So if I add 2 to it, what happens? You see how it moved 2 to the left? So it kind of moves like in the opposite direction of what you might expect. Okay, so by adding plus 2 inside the parentheses, that moved to the left. So what do you think if I do minus 4, what's that going to do? That's going to move, let's turn this one on. This is the blue function. So here's where I started. This moves 4 to the right. So this is what horizontal translations are. They work for all functions. It's not just a trig thing, okay? So I want to show you this with one more function, just to really kind of drive this home before I show you the graph of cosine. So let's take like the square root of x. Okay, so I've got the square root of x. So if I add 2 immediately to it, so look what happens. It moves back. It moves back, and it's actually moving back 2 units to the left. Okay, so now let me compare that to square root of x minus 4. So see how it moves 4 units to the right? So these are horizontal translations. Okay, so in the context of cosine or sine, doesn't matter which one you want to use. So here's my regular graph cosine, so that's the dotted black line. So if I add 2 to this, just watch what happens. So it's a little bit harder to grasp what's happening if you don't understand horizontal translations. That's why I showed you the other functions first. But it's still moving really the whole cosine function. It's moving it to the left, okay? So it's moving it to this direction. And then if I were to take this cosine of x minus 4, so again, it's kind of hard to capture in some ways, but like it is moving the graph now in the opposite direction. It literally works the same as the first 2 translations, but because these are like wavy functions, it can be a little harder to fully grasp it. So that's why I showed you the other functions first. Now there is some special vocabulary with horizontal translations when we have trig functions. So we have the word phase shift. This is what we call horizontal translations with circular or trig functions. So you might hear the word phase shift instead of horizontal translation, but it means the same thing. And then we also have the term argument. So if I have this x minus d movement, the x minus d is called the argument. So there's just a little bit of special vocabulary that comes up with this. Okay, so that was horizontal translations. So now let's talk vertical translations. So I want you to notice how this looks a little bit different. This is c plus f of x. So it's some number that's clearly outside of the function. So if you have c, this is going to move the graph c units up, or if you have minus c, that's going to move c units down. So once again, why don't we just take a little field trip so that we can understand how this compares. So once again, I'm back at Desmos. So we'll start back with our x squared again. So just notice how I've changed these functions. You see how the number now, like visually, it's like falling outside of the function versus what we had before where the number was like kind of inside with the x. That is a big distinction to make. Okay, so if I just add 2 on the outside of the function like you see here, so here's my x squared. So watch what happens when I add 2. The graph moves up 2. Okay, now what about if I subtract 4? What happens in this case? So now if I have x squared minus 4, so now notice it's moved down 4. So this is what vertical translations do. They move your graph up or down. So I want to just compare that. Again, this works for any function. It's not just like trig functions. So I'm just choosing some other random functions. So if I have square root of x, that'll be my dotted black line. So if I add 2 on the outside, I would hope it moves it up. It does move it up, so we can see that here. And then I've got x squared minus 4. So if I turn that one on, Now you can see it's moved the function down. So again, makes sense. So now if I do this in the context of having my trig functions, so let's use, this is my kind of base function, cosine of x. So if I add 2 on the outside, you can see it's just moved my entire cosine function up 2. And then if I were to subtract 4 like I have over here, now you can see that it just moves my whole cosine function down 4. So that is what these translations do. So what makes this very tricky, I think, is that we have also amplitude and period. So it's super duper important that you can detect amplitude and period versus translations, because by this point you should have already seen amplitude and period. So what we're going to do is I first want you to be able to kind of crack the code of these types of functions. So we're going to have a ton of exercises to get you really visually used to looking at these functions and knowing the difference between the translations, the period, and the amplitude. So that's what we're going to identify. So with period and amplitude, the types of functions that we were dealing with, you know, this was the format that we had before, a sine b of x and a cosine b of x. So if you have a number directly in front of and attached to sine or cosine, you take the absolute value of it to get the amplitude. And then if you have a number directly attached and being multiplied to x, you can figure out the period. So just a little reminder of that. Okay, so in this example that I'm looking at here, notice I have no number in front of sine and I have no number really in front of the x, okay? So what that tells me then is that the amplitude is 1. If there's no number here, we just assume it's 1. And then for the periods, remember we use that formula 2 pi divided by 1. This would just be 2 pi. So we have no number here, no number here, but we have this plus pi. So this part here, this is a translation. It is a horizontal translation. And then this means that we move pi over 2 to the left, okay? So if we're moving plus pi over 2, we don't move to the right, we actually move to the left. So that can kind of mess with people's heads. Okay, so let's compare that then to the next example. So I've got cosine of x minus pi. So what's the amplitude and the period? Well, the amplitude and the period, again, are just 1 and 2 pi. So again, they have no numbers kind of connected to them. This is really the thing that we're worried about here, this minus pi. So what does this mean? This means that we move pi to the right. So this is kind of your goal in this set of exercises, is to eventually be able to say all the different translations. Okay, so let's move on to these two examples. So I've got y equals 2 minus sine of x. Okay, so what's my amplitude and my period? That you should be able to figure out first. So the amplitude is 1. So remember, it's not going to be minus 1. So we know that this would be the sine function flipped upside down, but the amplitude would still be 1. And then the period is 2 pi because there's nothing attached to the x. Now, what we do have is this 2 here. This 2 really falls on the outside of the function. So that means that our sine function would move up 2. Okay, so we've looked at a couple of those now. I think you can identify what happens in the next function, so I would challenge you to pause the video for a second and just see if you can identify it, then hit play. Okay, so with the next one, so our amplitude is 1 and our period is 2 pi, so we still don't have anything different with that. However, this is telling us that we're moving up 3 because this number really falls outside of the function, and then this number is falling inside, so it's kind of attached to that x. This is moving to the left 2. Okay, so now I have some examples where I'm bringing more in with amplitude and period. So taking a look at E here, so now I've got minus 4 plus 1/2 cosine of x. Okay, so with this one, my amplitude is 1/2. So when you have a number directly in front of the trig function, that's going to be your amplitude. I don't have anything in front of the x, so the period's just going to be 2 pi here. So then I have to figure out what is this minus 4. This minus 4 means that I moved down 4, okay? Now what about for this other one? So what's my amplitude and what's my period? Well, in this case, my amplitude is 1. So now I have 3x. So this number here means now I plug it into that formula, 2 pi over b. So this becomes 2 pi divided by 3. That would be my period. Now, we haven't finished with this, right? We still have this plus pi. That means that I'm going to move to the left pi. All right, so moving on to the next one. So I actually started this one for you guys. So this next one, so I've got g here. So I've got 2 plus 3 sine x minus pi over 4. So I accidentally already wrote this down, but the amplitude in this case, the number in front, that means that there is amplitude of 3. There's no number attached to the x, so the period is just going to be 2 pi in that case. So now I have these two numbers here. So I would recommend, again, just take a second, pause for a moment, see if you can decide which way this is going to move. So this is moving up 2 and remember it moves in the opposite direction, right pi over 4. Okay, so what about h? I highly recommend that you just pause video here, just see if you can get the whole thing. This is super key to graphing these, if you can kind of break down these functions. That's why we're spending all this time on this, because once you crack this code, the next part becomes a lot better. So it's very important that you're able to do this. So pause and then hit play when you're ready. Okay, so here my amplitude is 2, and then I've got this 3 attached to the x, so my period is going to be 2 pi divided by that 3. Now I have to worry about this 1 and this pi over 2, so the 1 means that I'm moving up 1, and then this plus pi over 2 means that I'm moving to the left pi over 2. Okay, so I've got these last two here. Again, these are the last two I'm going to go through just to make sure that you are cracking the code. Pause, hit play when you think you've got them both. Okay, so I've got an amplitude of 4, that's this number here, and then the period of 2 pi over 3, so again, just taking that part there. Then I'm going to move up 2 and to the left 1. And for j, so for j, I have an amplitude of 2, this number here. The period is 2 pi divided by this pi, so the period will just work out to be 2. And then I'm going to move up 3 pi and to the right 3. Okay, so that was the first part, cracking that code. When we get into graphing, you're going to see why that matters. That's kind of the first thing that you want to know. The next thing is, so when we have a period other than 2 pi in a horizontal translation, the starting point will no longer be 0 when we're setting up our tables. It requires a little work to figure out what the starting and ending point are, and I have a little exercise to help you figure that out. So I'm going to show you this. So we're going to recycle some of these exercises we were just looking at. So we want to find the starting point. We're also just going to end up having this end point. And the way that you do this, you take whatever the inside of your trig function is, and you set up a 3-part inequality like this, and you solve this for x. So if you don't know how to solve this for x, so just think about, how do I get x by itself? I have x plus pi over 2. So to get x by itself, if I wanted to get it by itself, I just want to subtract pi over 2, but I do that to all 3 sides. So it'll look like this, minus pi over 2, minus pi over 2, minus pi over 2. And then you just finish solving for x. So in this case, I would have minus pi over 2 is less than or equal to x, which is less than or equal to 3 pi over 2. So this is a very handy little hint, because this will always stand for where you want to start your interval when you're setting up your tables. You'll see how to use this in a few minutes. And then this will also be a helpful guide as to where your intervals should be ending. So this is actually a very good check, because you can get a little lost with some of these translations. So knowing where you should be ending is a really good check to have. Okay, so let's do that one more time with b here. So I've got y equals sine of 3x plus pi. So I just rip out the inside here. And when I do that, I'm going to get the 3-part inequality again of 0 is less than or equal to 3x plus pi is less than or equal to 2 pi. So you always set this in between 0 and 2 pi. You go through and you solve. So to solve for this, so just think about, how would I solve for 3x plus pi? How would I just solve for x? First, I would subtract the pi. And then I have this inequality, and so then I just divide everything by 3. And so now I have negative pi over 3 is less than or equal to x, which is less than or equal to pi over 3. And so this would be where I'd want to start my table, and then this is where I would hope that the first period would end with my table. So again, you'll see how to use this. Okay, so I have 2 more examples like this. Again, super, super important. If you know how to do this, once I start showing you the graphing, you're going to be like, oh, okay, I understand where this goes. So I know I'm doing a lot of prep work here, but we are going to get to this, I promise. Okay, so what about if I have something a little more complicated looking? What do I do now to figure out where this starts? So as far as where the starting point goes, you always just focus on this inside part. You don't care about the rest of the stuff going outside of the function, okay? And you'll see why in a few minutes. So once again, I just set that inside. I set it between 0 and 2 pi again, and then I just go through the work to solve it by subtracting the 2 pi. And now this one might look a little more algebraically tricky when I divide everything by 3. But when I divide everything by 3, so this comes out to negative pi over 6 is less than or equal to x, which is less than or equal to pi over 2. And if you're wondering where I got to that, so I've got the work over here. So when I divide negative pi over 2, when I divide that by 3, it really comes out to negative pi over 2 times 1/3. So that gives me the negative pi over 6. And then I've also got the work here if you want to pause and just read that over. Okay, so once again, this is where I'd start, this is where I'd end. So we just want to make sure we're interpreting this right. So I would like you to do this last one on your own if you haven't been trying these on your own. Again, like once we start the graphs, if you know how to do this, you're going to be in a very good spot. So pause here, hit play when you're ready. Okay, so I set that inside part in between 0 and 2 pi. First, I'll go ahead and add 3 to all sides, and so then I'm left with this inequality. Divide all sides by pi. Now just be careful when you do this on the right side. This is 3 over pi is less than or equal to x. And then if I just divide this into 2 different fractions, this will simplify to 2 plus 3 over pi. Okay, and so this would be where I'd start, this would be where I'd end. All right, so now I'm going to finally show you how all of this comes together. So we're going to graph this example here. And okay, first things first, just looking at this, this is the graph of sine moved pi over 4 units. Is it to the left or to the right? It's moved to the left. And then where do I start? So if I wanted to figure out where I start, I just take this inside part, I just subtract off the pi over 4 from all sides. So I would start here at negative pi over 4. So the first thing that you do with this information is this is where you start your table, okay? That's very important because you're no longer starting at 0, so you have to figure out where you start. Next, we need to figure out period and amplitude, which if I'm just looking at this, I know that my period is going to be just 2 pi, and the amplitude is just 1 because I have nothing attached to the x and I have nothing in front of the sine. So just like before when we've been graphing with periods, and we know that this is now shifted to the left, the only thing that we really need to know are what are the steps that we need to make. So if I take that 2 pi and divide it by 4, what I need to do is I need to take pi over 2 steps, okay? So what I mean is if I start with that negative pi over 4, here's my starting point. If I add pi over 2 to it, this would be the first step that I take on the graph. So I add pi over 2 to this and get pi over 4. And I just now keep adding these pi over 2 steps. And you might want to remember pi over 2 is equivalent to 2 pi over 4 when you're doing your math here. So if I continue this, so if I take pi over 4 and add 2 pi over 4 to it, that'll give me 3 pi over 4. And then if I add 3 pi over 4, if I take 3 pi over 4 and add 2 pi over 4 again, so I'm just adding, that pi over 2 step, that'll give me 5 pi over 4, so there's my next step. And then if I continue that on, I'll get 7 pi over 4 and 9 pi over 4. Okay, and I just want to take a moment to remind you of the work that we were just looking at. Remember, we were looking at where the interval starts and ends. We just hit that 7 pi over 4, so we can see that we are on the right track with how we've set up our tables, okay? So that's a good thing to see. So from here to here, I would expect this to be 1 period, and then the period starts over again here. Okay, so I know it's a lot of work. Okay, so this work is really essential because after you figure this out, the nice thing is you've figured out kind of the hardest parts. The rest of this now is just kind of doing the calculation. So we just have to go through and find the y's. So I've got my table set up, and so now I'm just going to go through and solve for this. So if I plug in negative pi over 4 into this function, so that'd be negative pi over 4 plus pi over 4. So look at what happens. This gives me sine of 0. Sine of 0 is just equal to 0. So if I move to the next one, pi over 4, sine of pi over 4 and sine of pi over 4 is going to give me sine of pi over 2. Does this feel familiar? Because this should feel familiar to how we've been working with period and amplitude before in terms of like what these functions kind of simplify to, because then this will just equal 1. And then if I continue on to 3 pi over 4, so if I plug that in, this is going to give me sine of pi is just equal to 0. And then if I continue on to 5 pi over 4, continue on in the table, and I add this up, I get sine of 3 pi over 2, which is negative 1. And I can just continue to fill this table in 0 and 1. So even though this was really pretty crazy to try to get this set up at first and to do that startup work, like the outcome here ends up feeling very familiar to what we've seen in the past. It's not always going to be the case, but you can see kind of how these values are kind of going. Okay, so now, and then once again, just notice that we have the right end of the period. Okay, so now we are ready to go. We've got our table filled in, and I've talked about this in other videos. Once you have this table filled in, you're basically ready to start creating your graph. So you want to create your axis and then plot your points. So I'm going to make my axes, I'm going to go in pi over 2 intervals, and then here's 1 and negative 1. And so now I can just go ahead and plot all my points. And so if you are playing along at home here, I highly recommend that you pause and go ahead and plot your own points and then hit play when you think you've got them. Here are my points all plotted out. So I took the time before I made this video to go ahead and plot those. And I can connect everything. And so this does look like sine, right? Except it looks like it has just been moved pi over 4 units to the left. Like literally, look, the starting point has been moved over to the left. Okay, so that makes sense. And then if I want to graph the whole thing, I can just go ahead and I can plot a couple more points, just continue on the pattern, bada bing, bada boom. You know, you can just keep going with that however you want to do it. Okay, so that is one graph. I have a couple more graphs I want to show you. So what about if I have just a vertical translation? So what about 1 plus cosine of x? So the nice thing is with this, that like, first of all, with 1 plus cosine of x, does this move 1 unit up or down? This is going to move 1 unit up. And the good news is this is actually be significantly easier than when you have the horizontal translation. So that is the good news. So as far as like what my period and my amplitude are, so my period is 2 pi, my amplitude is 1. And then I know that if I just take 2 pi divided by 4, I'm just going to go pi over 2 steps. And there's no other funny business with like how to start your intervals. Since I don't have a horizontal translation here, when you do not have a horizontal translation, you get to just start at 0. So that's the good news. So if you have a horizontal translation, then you have to go through all that work of, you know, the starting with 0 and 2 pi. But if you don't have that, then you can just start at 0. And then I can just take pi over 2 steps after that, like I've always done. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. And then I can go through and I can start calculating my y values. So if you only have a vertical translation, this is a little bit like more intuitive in some ways. But now you just have to be careful when you're calculating this. You have to take 1 plus each one of your results. So cosine of 0, for instance, is 1. So at 0, I'm going to have the point 0, 2. That's what this 1 is doing. It's moving everything up. So you're going to have like slightly different y values. Okay, so what about 1 plus cosine of pi over 2? So plugging in the next value. Well, that's just going to be 1 plus 0, so that's just going to equal 1. So we can just put a 1 there. And then 1 plus cosine of pi, that's going to come out to 1 minus 1, so that's going to equal 0. And then we can just keep going with it. I've got the rest of the work here if you want to see that and check that out. Highly recommend when you're doing this that you make sure that this work makes sense to you. Now, you'll notice that my y's are a little bit different from back when we were talking about graphs with just period and amplitude. So because this has shifted my y's up, I no longer go into negative numbers. That's okay, but we still have this rise and fall with our y values. We can still kind of see that, and we'll see how this plays out now in the graph. Okay, so I've got all my values, so I can go ahead now and set up my table. So I've got 0, 1, 2. I'm going to go in intervals of pi over 2, and then I can go ahead and plot my points again. And again, I recommend that you just take the time on your end to also plot your own points. So I've got all my points plotted here, and then I can go ahead and connect them. And then if I want to really blow this whole graph out, I could just continue the pattern like you see here. So I've continued my dots here, and I can connect them. And so now I've got this nice robust graph of 1 plus cosine of x. All right. So now let's get crazy. So let's use negative 1 plus 1/2 cosine of 2x minus pi. So let's just throw the kitchen sink at this now. Because ultimately these are probably like some of the harder graphs to do. But if you can crack that code, you're going to be in a pretty good spot with these. So just starting with this, how does it translate? So I'm not talking about period and amplitude, just how does it translate? Up, down, left, right. Maybe you want to pause for a second and just think about that on your own. So this negative 1 means that the graph is going to move down 1. And then also it's going to move to the right pi units. And so now we've got to figure out taking this whole inside part. So because we have a horizontal translation, when you have a horizontal translation, you need to take the time to figure out where is your starting point. Okay, so I'm going to go ahead and I'm going to solve this 3-part inequality. I would highly recommend that you do this on your own and hit play when you're ready. So I'm going to go ahead and add pi to all sides. And then I've got this inequality. I can divide all sides by 2. So my starting point is pi over 2, and then my ending point should be 3 pi over 2. So just note, start, end. Okay, so I'm going to take this pi over 2, and I'm going to go ahead and I'm going to plug it into my table now that I know where I'm starting. And now we need to figure out our period and our amplitude. So my period in this case, if I'm looking at this, this is 2 pi divided by 2. My b is equal to 2. So my period is 2, and my amplitude is 1/2. There's this 1/2 right in front here. Okay, so now what kind of steps do I need to take? If I take pi divided by 4, I need to take pi over 4 steps. So with this table now, I start at pi over 2, and I take pi over 2 steps. So I just keep adding pi. I add pi over 4 steps. I think I said pi over 2, sorry. Okay, so what I'm going to do here then is I take pi over 2 plus pi over 4, that equals 3 pi over 4. And remember, you're going to have to get your common denominators, so just pi over 2 is equal to 2 pi over 4, so you can do the math there. Okay, so 3 pi over 4. So now if I add another pi over 4 to it, that'll come out to just pi. If I add another pi over 4 to this will come out to 5 pi over 4, 3 pi over 2, and 7 pi over 2. So if you don't believe these, I would recommend that you just pause the video here, take your time to make sure that you get these as well. And something I want to point out here before I go any farther, that 3 pi over 2, remember that was the end of our interval. So just a few moments ago when we were doing all this math, we said 3 pi over 2 is where I was supposed to end. And lo and behold, that is where we have ended. So that is good. Okay, so again, I know this feels like a lot, but this is like the most important step here. After you figure this out, it's now just a matter of doing the calculation, plotting the points, like so you don't have to, worry quite as much once you get this part set. So let's go through and let's calculate these. Now the calculation, you just do want to take your time with this. So when I plug this in, so I'll start with pi over 2. So I plug pi over 2 into this function. So I have 1 plus 1/2 cosine of 2 times pi over 2 minus pi. Okay, so I got to work this whole inside part out. So this is going to be 1 plus 1/2 cosine. This part here comes out to pi, so I'm left with pi minus pi. And so I'm left with 1 plus 1/2 cosine of 0. Cosine of 0 is just equal to 1. And so this comes out to 1 plus 1/2, so this will equal 3/2. So this is definitely going to take some work to figure out. So I would recommend that you pause the video here and that you try to figure these parts out. I'll show you all the work, but just to help you get the most out of this and to help you feel a little bit more confident, again, I recommend that you pause the video here and see what values you get, and then I'll show you all the work once you're ready to hit play. Okay, so continuing on with 3 pi over 4. So I plugged 3 pi over 4 in. So when I simplify this is going to simplify to cosine of 3/2 minus pi, which is going to come out to cosine of pi over 2. And cosine of pi over 2 is just equal to 0. So this is going to be with 1 plus 0, which just equals 1. So that's what I'm going to put in the table. Okay, I'm going to show you the work for the next points too. So plugging in pi, so if I plug in pi, this inside part will now turn into 2 pi minus pi. So as I simplify all of this, I'm left with 1 plus 1/2 cosine of pi. And so then cosine of pi I know is equal to -1. So this is going to leave me 1 plus 1/2 times -1. That comes out to 1 minus 1/2. So this will equal 1/2. So I plug that in. All right, continuing down the line, 5 pi over 4. So this is definitely an exercise in just calculation at this point. All right, so working this out, you'll see that I'm left with the inside will turn into 5 pi over 2 minus pi. So this will come out to 3 pi over 2. So if I work all of this stuff out, once again, cosine of 3 pi over 2 is just equal to 0. So with cosine of 5 pi over 4, that will just come out to 1 because I get 1 minus 0. So it goes like that. Okay, and I will show you the work for just the other two entries in case you worked on these yourself. So for the next entries, I should have gotten 3/2 for this last one, and then the period's going to start over again, so then you should have gotten 1 for the if you worked your table out to 7 pi over 4. Whew. Okay, so a lot of work to figure that out. However, it's just calculation, right? So you do want to keep this in perspective of kind of like what it is that you're doing here. Okay, so now I have all my points. Now it's just a matter of coming up with the axes. So notice how I've set up my axes in this case. I have for my y-axis, I have 1/2, 1, and 3/2. So I've kind of set this up so that I can make it easier to graph. And then I've also set up, I'm going to go in pi over 2 intervals on this graph down here. Okay, and so from here, now I can go ahead and graph my points. And again, I would recommend that you just pause and graph your points. So there are my points just all graphed out, and there I am connecting them. And then once you get that part set, you can continue the pattern to create the rest of the graph. So here I am making a couple more points. You can see them kind of plotted here. And so I can just continue that way. And so there's my whole graph. And okay, so yeah, lots of stuff goes into that. So I really wanted to break down that whole process. And if you found that helpful, consider leaving a like or a comment, sharing it with a friend. And then otherwise, I'll talk to you guys next time, guys.